Thank you, and once again, welcome to the release preview for SimXpert 2010. My name is Sunil Tahil Ramani, and I'm the Product Marketing Manager for SimXpert product line. In this webinar, I will be covering some of the major developments in this release. Let's look at the agenda for today. We will begin by providing a quick overview of the SimXpert product line for those of you who are new to the SimXpert product from MSC Software. We will then jump into some of the highlights of the SimXpert 2010 release, including areas of usability, geometry meshing, post-processing. MD Nastran 2010 was released just a few days ago, and SimXpert 2010 provides a comprehensive coverage for the new release of MD Nastran, so we'll be talking about that. We'll also be covering some of the enhancements in Motion Workspace, and a new Systems and Controls workspace has been introduced in this release, so we'll be talking about that as well. Before summarizing or concluding today's webinar, we will be covering some of the documentation enhancements that have been made available along with this release. So what is SimXpert? SimXpert is a platform to perform end-to-end simulations for multidisciplinary engineering, and it comes with a rich set of tools that allows easy model building for different simulation disciplines that include structures for linear and nonlinear static and dynamic analysis, multi-body dynamic simulations with rigid and flexible bodies using the Motion Workspace, crash, impact, drop test, and other explicit analysis computed using LS-DYNA and MD Nastran Solution 700 using the crash and explicit workspace, and the newly introduced Systems and Controls workspace that we'll be talking about later today. It has some unique capabilities such as native CAD access, allowing you to access native CAD geometry from leading CAD packages including CATIA V5, Pro Engineer, Unigraphics, and so forth. No data translation allows greater flexibility and control and makes parametric changes possible in your geometry. Simulation process automation with templates allows best practice capture and reuse later across the extended enterprise, also including the supply chain if needed. It allows engineers to capture actions as macros, which can be replayed later or used as templates. The obvious advantage is the increased productivity that can be achieved in the modeling and the reporting and the post-processing stage with the use of templates. So with SimXpert, we provide a complete multidisciplinary engineering environment that allows you to perform a spectrum of different analysis that includes structures, statics and modes, mechanisms with multi-body dynamics, systems and controls that we'll talk about later today, and safety and crash simulations that can be seen here on the screen, and thermal and heat transfer analysis as well as NVH. So let me now jump into some of the enhancements in the SimXpert 2010 release, starting with usability. We have made quite a few changes in the areas of view manipulations. Our new default scheme is based on middle mouse button for rotation and follows strong industry conventions. Using the available options to set the shift and control modifiers, the default rotation center, and also the zoom direction, we can mimic the gestures for rotate, pan, and zoom of leading CAE and CAD tools such as Patran, UGNX, SolidWorks, Pro Engineer, and SpaceClaim, to name a few applications. An alternate scheme following CATIA's gestures is also available, and based on the strong feedback that we have received from our users. In the default scheme, the middle mouse button is used for rotation. The shift and control are used as modifiers for pan and zoom. Pressing and releasing the second mouse button may also be used for easy model inspection and travel. And to pan without using the keyboard, use the right mouse button. If you're familiar with any of the common CAD packages, you will feel at ease quickly with SimXpert performing view manipulations. In SimXpert 2010, we have made interacting with dialogues easier. Now you have auto advance, which means the pick focus moves to the next field automatically once you have reached the required number of entities for the field. This minimizes the need to directly interact with the dialogue. And auto advance will automatically advance to the apply button once all the fields are populated with their required information. Turning on auto apply means that the apply button will automatically be invoked right after the last field is satisfied. This is convenient when performing repeated operations. In summary, we have minimized the need for direct dialogue interaction, and we also have intuitive gestures when you do need to interact with the dialogue. Enhancements in the area of picking provide fingertip access to useful picking methods. Some of these new picking methods have been listed on this slide. Users now have the choice of using a circular outline to make a selection. Using the shift key to perform a shortest path selections, it is now much easier to select continuously between two nodes or elements, reducing effort in using multiple entities. With F8, you can turn on exclusive or inclusive picking, where partially enclosed entities are also selected. Some of the graphics improvements include screen symbol labels and global control and individual object control. And users now have the ability to have numerical values for force graphics. So all of these usability enhancements make it easier for users to work within the environment and have significantly reduced the mouse travel as well as the clicks that are required to perform a particular operation. Let me now jump into some of the geometry and meshing enhancements. I'll start off with geometry. Native CAD access has been available in SimXpert since the very first release, and with this release we have made some enhancements to native CAD that include reducing the memory footprint, improving the performance, smart update improvements, and updates to ProE to include wire bodies and materials. The native CAD versions that are supported have been updated with CATIA V5 R19, ProE Wildfire 4, and Unigraphics NX6. A new set of comprehensive geometry creation tools have been now made available within SimXpert, and with the new ribbon layout and new pick recipes that we discussed before, it becomes much easier to create and make edits to the geometries within the SimXpert environment. Previous releases of SimXpert did have a subset of these current create and edit tools, but now the list is much more expansive, and you can create powerful geometries from within SimXpert. This eliminates the need to make edits by going back to the CAD system, and with the new ribbon layout as well as the picking recipes that we discussed, it makes it much easier to make modifications and makes creation of geometries very efficient. An interesting new feature is the capability of native CAD geometry and parasolid models to coexist within the same SimXpert session. And what this allows is that the geometry tools are active even after native CAD attach has been performed. So you can edit geometries or use geometry tools on parasolid geometry even after native CAD attach has been performed. This is a new capability in SimXpert 2010. Previously, if you had a new native CAD geometry, parasolid models, import of parasolid models was not allowed. Enhancements in this area of mid-surface extraction include consolidation of mid-surface actions such as automatic extrude and manual offset. And clearly there are enhancements in these areas of offset, editing surfaces, and splitting by curves. A lot of time is spent during modeling to clean up the geometry and extract the mid-surface. And all of these automatic mid-surface extraction tools have made it easier to use and work with geometry and make the geometry ready for meshing. Let me now talk about the new geometry cleanup tool. There's a new streamlined user interface for geometry cleanup as shown on the screen on the right. And it also has some simplified outputs that you can use to clean up your geometry rather quickly. And the new tool provides functionality to clean up geometry by suppressing and modifying the topology. So here you see a geometry that on which this geometry cleanup tool was used, and we get a much cleaner geometry that can be used to get a much better mesh compared to the previous releases. Let me now talk about some of the meshing enhancements in this release. And a new TET mesh quality fix technique has been implemented that includes node smoothing, face swapping, splitting the longest edge, and moving nodes and fixing bad trias. In prior releases, there were limited sets of mesh improvement techniques available, and with this release, we have provided a much comprehensive set of quality fix techniques that result in a improved mesh quality and better compliance with Nastran metrics. There are several new options available in meshing. As you can see with this dialog box, we can now input the start node ID and start element ID in the mesh user interface. And also quality enhancement option is used to fix the bad elements that fail the quality check. So automatic fixing of bad elements provide an ability to control the start node ID or element ID, provide much better control during meshing and a much better mesh quality since the mesh you get is much more robust. Nastran Geom Check and TET10 linearization have been added to this particular release, and you can see the two on this check ribbon on SimXpert 2010. What the Geom Check allows you to do is it works on both solid elements and shell elements, and within a single click you can get the failed element IDs, and all the failed elements are collected in a group in a sense. And the TET10 linearization is used to fix the TET10 elements that fail the Nastran Jacobian check. Both of these utilities allow you to get a much better mesh and ensure that the mesh generated can be used by Nastran for solving. Output of incomplete mesh is also now possible once the meshing fails in SimXpert 2010. So if tria mesh on solid faces is self-intersected, TET meshing will fail, and a dialog box is now made, or dialog box pops up which asks the user if he wants to output the tria mesh. This dialog box is shown here, and if and all of the failed mesh is then collected in a group called failed mesh. So you can provide better diagnostics during meshing, and provides better user control for debugging. There have been several geometry check enhancements that have been made available in this release. If once you have a geometry model, users can provide different options of mesh size, internal angles, and Jacobians, and then model check features such as suppressing vertices, small faces, small edges, detecting some of the sharp features and small angles. You can get an output that contains the list of entities meeting all the user criteria. So all of these geometry check enhancements are useful in getting a much better much better mesh control and much better mesh ready for Nastran solve. So here I'm showing that the original model contains some vertices and some small edges, and after the suppression operation you have these long edges with much fewer vertices, and you have clearly detected and removed undesirable vertices, small faces, small edges, and angles with this automatic suppressing utility. Again, similarly, autofix small edges. Here in this case, we are fixing the small edges, and the final model after suppression, as you can see, is a much better mesh and a much cleaner mesh. Autofix small angles. So when you do the face merge operation, few sliver surfaces may not be cleaned, and specifically this can happen when the break angle is large. And in order to handle these sliver surfaces, autofix small angles provides a way to get from this original model to this final model using the suppress operation. Autofixing of narrow regions. Narrow regions are two edges which are close but not directly connected, and you introduce a double split and suppress one of the closest close edges. Again, all of these geometry check features are provided for better meshing control and detection and merging of undesirable edges in this case. Surface meshing quality improvement. So detection and merging of undesirable elements leads to a much better mesh quality. As you can see, the before and after picture, you get a much better mesh with this with the new features that are made available for meshing in SimXpert 2010. Minimal meshing and hard geometry meshing is now supported in this new release, and hard curves and hard points are now imprinted on the mesh, as you can see on these images on the right. And we also support virtual surfaces and virtual hard curves. So clearly the advantage is better control on curve association with surfaces and a much better mesh quality with these features. Washers around small holes and quad meshing has been made available. Again, as you can see in this dialog box, you're now able to specify how many layers of washers you want and what is the element size for those layers. And I'll go to the next screen that shows the mesh with the no washer, and then with one layer of washers included around the circular hole, and then 2 layers and 3 layers. So you can see, you can clearly easily specify how you want the washers around the small holes in the quad meshing. Here we have same situation with no washer in the beginning, and then 1 and 2 layers of washers, giving a much cleaner mesh, which is very easily consumable by Nastran. Meshing consistency. Previously we had that meshed entities based on memory address. But with this release, then Mesher now meshes the entities based on a geometric construction order, and clearly you get a much consistent mesh, and on test models the element count variation reduced by 3 orders of magnitudes in our tests. So meshing consistency has been improved with this release of SimXpert 2010. Let me now jump into some of the key enhancements in the areas of MD Nastran 2010 coverage. We just last week announced the release of MD Nastran 2010 with several key enhancements in these areas of nonlinear completeness, nonlinear completeness and robustness, as well as solution 600 for implicit nonlinear, solution 700 for explicit nonlinear, and other enhancements in the areas of NVH, durability, and optimization. SimXpert 2010 provides comprehensive coverage of MD Nastran, including some of the new features that have been introduced in MD Nastran 2010. So MD Nastran has had nonlinear structural and heat transfer capabilities since its inception. However, MD Nastran 2010 introduced true thermal mechanical simulation capability. The multiphysics simulation capability employs an algorithm to ensure that both structural and thermal analysis time steps are synchronized and converged to provide a true multiphysics simulation. This new feature in MD allows for more accuracy by capturing the mechanical contribution to thermal problems. Typical examples include brake pads, electronic packaging, manufacturing simulations such as forging and rolling, and this is well supported in SimXpert 2010. As you can see, you can now set up the load steps, the thermal load step and the structural load step, and the corresponding output deck is shown here for both the thermal substep, and the structure substep. Thermal contact is implemented in MD Nastran 2010 in pure thermal analysis and coupled thermal mechanical analysis. Previously, you had to ensure elements and everything lined up, and you had a congruent mesh in heat transfer. The thermal contact feature improves efficiency in modeling time, and you can take components, for example, on a circuit board and swap out parts without having to realign the meshes. Again, this is well supported in SimXpert 2010. You have the option to define the contact table with the thermostructural option as shown here, and to generate the appropriate input deck shown on the screen. Analysis, chaining, and perturbation. Previously we had normal modes, brake squeal analysis, etc. But with the new MD 2010 release, we have added direct frequency response, modal frequency response, and modal transient response for perturbation analysis. And in addition to the perturbation analysis, we also have linear analysis in solution 400. What this allows you to do is to have a single run that does multidisciplinary simulation. you can have a single run on a single model with the multidisciplinary simulations. As you can see on this slide, we are doing a nonlinear analysis with perturbations along with a linear analysis in a single run, and a combined results database comes back for post-processing. Element offsets, this has been requested by our customers and is now available in MD 2010 and supported in SimXpert 2010. Offsets are incorporated at the element level. Previously you had to use rigid bars or rigid links at each grid with a rigid range for large displacement effects. This is very well supported in SimXpert. Pretty simple, you just have to tell which options do you want to have turned on or off. Automated bolt modeling is an enhancement in the areas of assembly modeling. We automatically calculate the preload. Previously there were utilities that could do this, but the process was a little bit cumbersome. Also, the utilities did not understand that you could have contact across the interface. The new feature in MD Nastran 2010, the automatic bolt creation, creates the MPC tying equations. There is continuous contact on bolt shaft if you have shear across the elements or other pressures. General method is now available for solids, shells, and beams. It is very well supported in SimXpert. You can see that you can now have a 3D bolt model, and there are a couple of options of either creating an automatic or an assisted method, and you can have a bolt preload of type either a force or a displacement, and the associated bolt card for Nastran is written out from within SimXpert. User-defined services has been introduced in MD 2010, and we can call user subroutines from within MD Nastran 2010, and this is supported using the user services option in SimXpert 2010. There are several items available for contact, like if you have your own recipes for calculating separation forces, brake squeal or friction, you can use those, or if you have your own element formulation, there is a user-defined service for that, and similarly for elements. So you can define your own behavior for contact elements and materials, and it is supported through this user-defined services options in SimXpert 2010. OpenFSI is a new and exciting technology introduced in MD Nastran 2010. OpenFSI architecture provides the capability to send data back and forth between the mechanical code, that is MD Nastran, and the CFD service. The CFD service could be a CFD code or an aeroelasticity code. A common OpenFSI application is where the fluid flow affects the structural response, and the structural response in turn affects the fluid flow. In such applications, the structural model must be coupled to a flow field solution in an external CFD code or user-defined application. So this capability was introduced in MD Nastran 2010, OpenFSI capability, and there is a wide variety of applications for this in various industries. Flexing of airplane wings, of commercial jets in flight, dynamics of ocean-going ships, door seal aspiration in the automotive industry, bending and durability of wind turbine blades, and the movement of flag in a breeze. All of this is now supported. The OpenFSI capability is supported from within SimXpert, and it accounts for structural deformations caused by fluid pressures and supports your pre-existing CFD models. There are other contact enhancements, rigid body growth, and clearly you can start off with a flat pattern and create a quick template, stent roll-up template, and set up the contact body problem and post-process all within the SimXpert environment. This example has been documented in our MD Nastran demonstration problem guide, and I'll talk about that in more details towards the end of our presentation. So other MD Nastran coverage is local adaptive mesh refinement control and parameters and hybrid damping control. Let me now jump into some of the post-processing improvements, and these are some of the highlights, since we may not be able to cover all of them in all details in this presentation. Some of the highlights include MPCs, RBEs, and well connections display, and completeness for supporting solution 400 and 700 types of analysis. Actions, charting actions is something we'll cover in this presentation. So let me jump into MPCs and RBEs display. Previously, no MPC or RBE element were shown when post-processing plots were rendered. With this release, we can now show MPC and RBE elements when a deformation plot is rendered. So pretty self-explanatory, and I'll now jump into similar slide on weld connections. So you can now display weld elements such as C-weld, C-fast, and C-seam when a deformation plot is rendered. So again, previously weld elements, there was no way to post-process weld elements, or they were when post-processing plots were rendered. Now users can better visualize all the three entities: the welds, the RBEs, and the MPCs when post-processing results. Several enhancements have been made to provide full access to solution 400 and 700 results. We have enhanced the direct results access to allow for full access of these solution 400 and 700 analysis results. So in this 2010 release, the enhancements that that are supported are for transient thermal analysis, the coupled thermal and static analysis, coupled nonlinear structural and thermal analysis, and coupled linear and static analysis. With the enhancements in post-processing, you can have full support of step and sub-step analysis, and review initial stress-free contact in your post-processing when you're post-processing your results. Color spectrum enhancement. So previously, when you had regions of the simulations that did not contain the results data, that were shown in a black color, and it was very hard to see, especially with the black inter-element boundary lines. With this enhancement, you can change the spectrum color change the spectrum color assigned to entities that have no associated analysis data. So clearly, the advantage is you can now have a much clearer rendering of rigid and flexible contact bodies, as you can see on the screen, and is applicable both in linear and nonlinear analysis, and especially contact analysis. With the SimXpert 2010 release, we have also introduced the capability to display and animate rigid and flexible body contact within the post-processing plots. So previously, this was not possible to. It was not possible to display the rigid body, and now with SimXpert 2010, we have the capability to animate 1D, 2D, and 3D rigid bodies, and animation of self and body-to-body contact of combinations of rigid and flex bodies. Plot definition control. I think I'll try to go through this rather quickly. So we have enhanced the actions that define the plots. So A generic action was previously available. Now there are new actions are created to control the display attributes and the numerical operation. So with SimXpert 2010, we have now provided a way to or we have provided initial charting actions to support creation and modification of charts. This was not possible in the previous releases of SimXpert. And with this you can now create templates with your actions to create and modify your charts, and macro record and replay playback is also available for all the charting attributes, and some of the charting attributes are shown on this slide here. So you engineers can now easily create their own templates for post-processing, and provides a much better control on post-processing for charting from within the SimXpert template builder environment. Export curve data to a file. We can the charting components property interface shown here on the XY chart properties. You can now add a spreadsheet display for the curve data. So in the previous releases, you could use only the curve data could only be viewed with a common XY chart, and now users can export the chart data so it can be used by other programs for further post-processing like Excel. Let's now look at some of the template builder workspace enhancements, and we have added the capability to perform template and action versioning, and what this does is it improves the clarity on how to handle and integrate new actions when more recent revisions are encountered. There are some other enhancements that include a new authoring user interface and an option to have embedded sub-template creation. Enriched actions. Actions have been enhanced to define tabs, radio groups, and booleans, as shown on this preview screen here. So previously, if you had to have a more fancier dialog box like this, you had to use a custom UI authoring in a tool like Qt Designer, but with this release of SimXpert, we have enriched our actions so you can easily define tabs, radio groups, and booleans. And this is again based on the requested functionality from all the users that have been using the template builder workspace for creating the templates. A big enhancement in the template builder workspace is a Python debugger. And what this does is allows Python scripts and templates consisting of Python actions to be analyzed in a standard debugging environment. So previously, this debugging your Python scripts was cumbersome, and you had to use print statements or trial by error. But now you can see you have different debugging tools available, like including breakpoints and execution points, and all of this is made available in the Python debugger from within the SimXpert script editor. The obvious advantage is it reduces the time to troubleshoot automation solutions, and makes it much easier to use the script editor from within the Python or within the SimXpert interface. Heartbeat has now been added to the templates, so actions have been updated to report progress, and actions that do not report progress will display an icon to indicate that the action is in process of execution. And actions that have been updated to report progress may be aborted with this stop icon that has been added to the templates. So all of these make it much easier for users to see the progress, and if the process is taking a very long time, engineers can decide to abort the process as well. Let me now jump into motion workspace enhancements. The biggest enhancements are in the areas of expressions and design variables, making it possible to have parametric modeling from within the motion workspace environment. Design time parametric expressions are now available in the motion workspace environment, and users can also define and reference their own functions by registering them in the options menu. So as you can see here, we support all the complete set of Adams view location and orientation functions, and some of the examples of this are shown in this on the screen. Design variables can be referenced in any of the property editors and across different workspaces as well. And what this allows you to do is create design variables that are of different types and allows for parametric model building and model simplification. So in this case, I have first defined the boom length and set its value to 100 millimeters, and I can then reference this boom length design variable in this property editor where I'm creating the cylinder. External Adams solver support gives users the option to run simulation from the SimXpert user interface using the external solver. So if you have an existing Adams installation, MD Adams installation that you would like to leverage, you can now use the external solver to make use of that particular installation, and it's particularly handy in case of large simulations. Previously, you had to either resort to an internal solver or export an ADM file to run the MD Adams solver externally. With the transportation extension that has been added to the motion workspace, you can now perform detailed tire and road modeling. And a library of standard tire and road models has now been made available in the installation. So previously you had to either use custom tire and road models, and this is standard tire interface compliant and can be used with all existing tires and roads from MSC software. Clear applications are in vehicle dynamics as well as in aerospace ground loads. A big enhancement in this release is an ability to export your motion model as a Python script. So previously you had to have a manually authored Python script and save your models as binary SimXpert files, but once you export the model as Python, you can quickly make changes to it and make easier auto generation of those models possible, and you can also get the output of the model in a stable ASCII format that you can view and modify. Geometry creation tools from within SimXpert motion environment. There have been new interface support for adding 2D wireframe geometry such as arc, circle, outline, and polyline, and you can now use these geometries for curve-to-curve contact or curve-to-plane contact for extrusion and revolution, and it supports the ADM import for arc and circle keywords for the graphic statement. So geometry creation, we covered that in the SimXpert structures environment. It's also made possible, the 2D wireframe geometry creation is also made possible in the motion workspace environment. In terms of flexible part creation, we have added a new tool for quicker creation of the flexible parts, and now you can create multiple flexible parts using the MD database reference. So instead of the MNF file, you can refer the master file from your Nastran run. So previously this was a multi-step process. You had to first create a motion part, switch to the flexible body tab, toggle the flexibility, and select the flexible reference. Now this flexible part provides a more efficient generation of flexible bodies to include flexibility in your motion analysis. Clearance object, we have introduced solver-based clearance calculation, and the clearance can be defined between either two rigid bodies or two flex bodies, and also between rigid and flexible bodies. And previously you had to have a custom subroutine in order to perform clearance calculations from within SimXpert Motion, and there are applications in all different industries, but this new clearance object allows you to include sensors and controllers to be based on the clearance calculation as well. Post-processing for the clearance analysis has also been included, and that includes dynamically drawing clearance objects during the animation, and the users can chart minimal distance or location of minimal clearance points on each part. This capability was only available in Adams post-processor, but has now been made available from within the SimXpert environment. Again, all industries examples are available in all industries, but some of those are listed on this chart here. So in prior releases, we did not have a way to perform scripted simulations, ACF based scripted simulations that the Adams community is used to, and you had to resort to Python scripting for scripted simulations. Like for example, if you had to deactivate a joint and so forth during a simulation, you had to resort to Python scripting. Now the ACF based scripting, which is Adams command file based scripting, is now made possible from within the SimXpert environment. Some of the other enhancements include Adams to Nastran interface, which has supports for dynamic operating point and exporting graphics using a wireframe approach. So as you can see on this slide, we have a SimXpert motion model of an ATV, and with the Adams to Nastran export, we have exported a Nastran input deck which has graphics include file for visualization, which is once you import that model into the structures workspace, you can see the graphics associated, the wireframe graphics associated with that as well. So previously, in previous versions of SimXpert, this was limited to static operating points. So now we have added support for dynamic operating points, and white box export makes it more user friendly, and we have also introduced other enhancements such as support for dummy parts and output styles that have been requested by automotive OEMs. Linear support has also been added for this release of SimXpert, so support for Adams linear model linearization, and you can linearize your models across about any operating point, such as initial conditions, static solutions, or dynamic solutions. And this is a new capability in SimXpert, and supports the Adams linear solver. User-defined objects are essentially UDEs from the Adams world, and provide a higher level aggregation object, and lets you aggregate different objects and manage a parametric collection of modeling objects through the Python-based implementation. So you essentially have the same behavior as the core objects, such as activate, deactivate, and so forth, but you can essentially get control of aggregation of objects and reuse for common modeling constructs. Flexible body nodal stress and strain export is now possible with this release of SimXpert. So you can load data for XY charting, and it's automated utility for generating the nodal stresses and strain reports. So as I said before, we have now introduced a systems and controls workspace and with this release, and in the motion workspace we have a clear integration with this systems and controls integration, or systems and controls workspace, I'm sorry, with this SC interface objects. The new SC interface objects will facilitate the inclusion of systems and controls and or Simulink models in the motion environment. And previously you had to use custom Python scripting for this, but now you can have a true multidisciplinary model with one or more flexible bodies, a multi-body dynamics model, and one or more systems designed in the systems and controls workspace. There are multiple applications that we can think of: anti-lock brake systems, active roll, steering, hybrid in the automotive world, flight controls, and landing gear hydraulics in the aerospace world, just to name a few. Max-min reporting capability has been added to the SimXpert motion workspace. So with this, you can track maximum and minimum values of results quantities. And previously you had to write your own post-processing scripts to generate this max-min report, but integration with Excel and user customizable ASCII results file clearly provides a way to for you to generate this report for easy data interrogation. So with this I'll come to the end of the motion workspace slides, and together with structures, motions, and systems and controls, we have a true multidisciplinary end-to-end user environment. What I'm showing here is an integration between the structures and the motion workspace. So for example, in this quarter suspension model, you can think of making the lower control arm flexible by exporting the lower control arm to the structures workspace and then bringing it back into your motion workspace for post-processing and reporting. The new systems and controls workspace that has been introduced in SimXpert 2010 provides a way to integrate not only with the motion workspace and the structures workspace, but also provides a comprehensive modeling capabilities with different libraries such as thermal hydraulics, gas flows, control systems, and more. And you can work with your existing EZ5 models, and also it interfaces with Simulink from MathWorks. Example of integration with Simulink is a powertrain transmission controller development. So the vehicle or the plant is modeled in SimXpert systems and controls workspace, and the S function generated by SimXpert can be used for co-simulation with Simulink. Some of the general analysis capabilities of the systems and controls workspace include steady state analysis that includes finding a good starting point for a simulation, linearized analysis for assessing the stability of any operating point, simulations, so palette of powerful integration algorithms, so forth, and data analysis to confirm functional relationships Automated model documentation is also possible, and you can export any model as an HTML or a text document as shown on the screen. And with this document that can be opened in any HTML browser, it contains information of your components, submodels, input-output names, and so forth. Similar to the motion workspace enhancement, you can also export the systems and controls model as a Python script, and this simplifies the reuse of modeling subsystem and promotes auto generation, as we said before, based on the stable text form model that you can easily edit. You can also export diagrams, schematic diagrams, as graphics files, and that can be easily included in Office applications such as PowerPoint or Word, and facilitates ease of reporting. So in summary, the Systems and Controls workspace provides a powerful systems modeling and simulation capabilities, provides a true multidisciplinary environment that with which we can now integrate motions, systems and controls, and structures all within the same environment. You can import and reuse your existing EZ5 models and libraries, and you can interface with Simulink models. SimXpert adds additional benefits to this SimXpert systems and controls workspace by providing the ability to capture and reuse processes, and data management with Sim Manager, and Python-based scripting that allows for ease of text form model generation that can be used for auto generation. Several enhancements have been made to our documentation. The formerly called MD Users Guide has been updated to with 17 new application examples and is now called the MD Demonstrations Problems Guide. There have been several new chapters introduced that have SimXpert tutorial slides, and there are embedded video content that you can activate from within the PDF that's available online on script.com. This slide provides a list of new chapters that have been added to the MD demonstration problems. Again, the intention is to provide users with a more comprehensive set of solutions and problems that they can use both SimXpert 2010 and MD Nastran 2010 with this new problem. So in summary, SimXpert provides an integrated multidisciplinary engineering environment consisting of specialized workspaces that include structures, motions, systems and controls, explicits, and so forth, allowing you to solve problems in all of these areas and also interacting with each other using the specialized workspaces. Native CAD associativity, making it possible to import native CAD geometry from leading CAD solutions, reducing data translations and allowing parametric access that allow you to change the geometry from within the SimXpert environment, and expert methods validation and publication, including Python record replay and best practice publish and retrieve, increasing the productivity gain from your simulation process by reducing the time to model, post-process, and report the results that are generated. Here are some of the contacts that you can reach out to in case of questions. So my name again is Sunil Tahil Ramani. I'm the product marketing manager for SimXpert product line. Vidya Shankar is the product manager for SimXpert, and Tim Gartland manages our motion product line from SimXpert. Thank you again for joining us today on this webinar, and I look forward to seeing you on our future webinars. Thank you.